Today we'll be doing a lesson on finding the surface area of all prisms using the lateral surface area. So in this lesson you'll learn the formula for surface area that can be used for any prism, as well as understanding what the lateral surface area of a prism is. So if we recall, a prism has two bases and rectangular faces. The number of rectangular faces is always equal to the number of edges on the base shape. In other words, if you have a triangular prism, you will have 3 rectangular faces because a triangle has 3 sides. A hexagonal prism will have 6 rectangular faces, and so on. The total surface area can be found by calculating 2 times the area of the base, since there will always be 2 bases, plus the area of the rectangular faces. Another name for the area of the rectangular faces is the lateral surface area. If we look at a rectangular prism, we see that the green shaded area represents the lateral surface area. The blue shaded area represents the 2 bases. So the total surface area would be 2 times the area of the base plus the lateral surface area. If we look at a triangular prism, again, the green shaded area is the sum of the rectangular faces, or the lateral surface area. The blue shaded area would be 2 times the area of a triangle, or the area of the bases. And again, the sum, or the equation, would be 2 times the area of the base plus the lateral surface area to find the total surface area. Hexagonal prisms, again, the green shaded area is the lateral surface area, where the blue shaded area represents the base area, and the total would be the sum of the area of the bases plus the rectangular faces, or the lateral surface area. So what is the formula for finding the lateral surface area while using dimensions on the prism? Because a triangle has 3 sides, all triangular prisms have 3 rectangular faces. Let's find those 3 rectangular faces. This first face on the bottom of the prism has dimensions of 4 times 8. The dimensions of each rectangle on this prism share a side of 8 centimeters. Look at this back side, 3 times 8. And this side, 5 times 8. The sides being multiplied by the height of the prism make up the perimeter of the base shape. If we unfold the prism, we get 2 triangles for bases and 3 rectangles. The 2 triangles would be 2 times the area of the base. Let's look specifically at the area of the rectangular faces, or the lateral surface area. The large rectangle is found here, and here is the one on the back and the one on the bottom, and they combine to form a large rectangle to form the lateral surface area. Notice that the total lateral surface area is found with the perimeter of the base as a side length, 5 plus 3 plus 4. And the height of the prism, 8, is used as the other side of the rectangle. So to find the lateral surface area, we multiply the perimeter of the base, or 5 plus 3 plus 4, which is 12. The lateral surface area is equal to the perimeter of the base times the height of the prism, 12 for the perimeter of the base, times 8, which is the height, and we get 96 centimeters squared. So the formula for lateral surface area is the perimeter of the base times the height of the prism, or capital P for perimeter of base, times lowercase h for height of the prism. If we write this out now in full mathematical form, you see that the total surface area is equal to 2 times capital B, or the area of the base shape, plus the perimeter of the base times the height of the prism. Let's look at an example using this formula. We start with the formula, 2 times the area of the base plus perimeter of the base times the height of the prism. The base of the triangle shape, as you see, is 4. The height of the triangle is 3. The perimeter of the base is 5 plus 5 plus 4, or 14. And the height of the prism, or the line connecting the 2 bases, is 15. So we start by substituting the base of the triangle, 4, times the height, 3, divided by 2 for the area of the base, and multiplying that by 2, plus the perimeter of the base, which is 4 plus 5 plus 5, or 14, times the height of the prism, which is 15. Be careful with your substitutions. Then we multiply, cancel out the 2's, and you get 12 plus 14 times 15, or 12 plus 210, or 222 centimeters squared. Remember, we're finding area, and area is 2 dimensions, surface area. Our second example is a right triangle. On a right triangle, the base and height are found by the line segments forming the right angle. Let's look at our formula. 2 times the area of the base plus the perimeter of the base times the height of the prism. The parts of our triangle show a base of 4, the height is 3, and the perimeter of the base is 5 plus 4 plus 3. The height of the prism is 8. The line connecting the two bases is equal to 8. These are very important dimensions to write down correctly so that you don't substitute incorrectly. 2 times the area of the base, which is 4 times 3 divided by 2, plus the perimeter of the base, which is 5 plus 4 plus 3, times the height of the prism. So we cancel out the 2's, and again we get 12 for the area of the bases, plus the lateral surface area, which is 12 plus 8, or 96. 12 plus 96 is 108 centimeters squared. This formula will work with any prism. In this prism, they gave us the area of the base. They told us it was 23.38. The perimeter of the base, each side length is 3. There's 6 sides on a hexagon, so the side lengths have a perimeter of 18. And the height of the prism connecting the two bases is 7. So we multiply 2 times the area of the base plus the perimeter times the height. And we get 46.76 plus 126. The surface area for this prism is 172.76 centimeters squared. Notice the lateral surface area is equal to perimeter times the height. So if they were only asking us for the lateral surface area, our answer would be 126. The surface area of a prism can be found using the formula 2 times the area of a base plus the perimeter of the base times the height of a prism. 2 times capital B represents the area of the two bases. Capital P times H represents the lateral surface area, or the area of the rectangular faces, which is found with the perimeter of the base times the height of the prism. Thank you.